Greetings of the day. Myself, Mrs. M. Bommy, Assistant Professor in CSE Department, Madanapalli Institute of Technology and Science. Today, I'm going to give some brief introduction about artificial intelligence, where we are going to discuss about what is artificial intelligence, agents and environments, rational agent, the nature of environments, as well as types of agents. So first, we will discuss what is intelligence. Intelligence is what? The capacity to learn and solve the problems. So in particular, we can view the intelligence as the ability to solve novel problems, the ability to act rationally, the ability to act like humans. It is just like how we are going to predict, understand, perceive, as well as model the outside world. So what is artificial intelligence? Artificial intelligence is a broad term which is going to mimic the human intelligence. So we can view the artificial intelligence as a computer system which is going to mimic the human intelligence, as well as it is going to simulate the problem solving capabilities as well as cognitive function of the humans. There are many definitions for artificial intelligence. Some of the definitions are organized in 4 categories like thinking humanly, thinking rationally, acting humanly, acting rationally. Based on this, I have quoted some of the definitions over here. So according to the definition given by Hujland, artificial intelligence is what? The exciting new effort to make computers things, that is like machines with minds in the full literal sense. So according to the definition quoted by Shalkov, artificial intelligence is a field of study that seeks to explain and emulate intelligent behavior in terms of computational process. Next comes the definition given by Rich and Knight. So according to him, artificial intelligence is what? The study of how to make computers do things at which at the moment people are better. So coming to the definitions, so it is what? Intelligent agent is what? Something going to be act rationally in the given situation. Rationally in the sense, it is going to do the things right based on the given situation. So understanding what is artificial intelligence, now we'll discuss about what is like agents and environments. So agent is anything that can be viewed as perceiving its environment through sensors and acting upon the environment through actuators. Here you can see the schematic diagram of a simple agent. So where we have an environment, the environment is the place where we are going to deploy the agent. From the environment, the agent is going to receive percept by means of the sensors. Through the received percept, it is going to create some actions by means of the actuators. So these actions are applied to the environment by which the states of the environment could be changed. In a particular moment, percept is what refers to a perceptual input at any given instant of the time. For example, percept is what? Like an input which is received from the environment. So based on the input received from the environment, the agent is going to map the input into action. So that is what we are going to call here as agent function. So the function of the agent is to map the given input function into some actions. So there can be many agents. For example, we take like human being as an agent. The sensor of the human agent can be like eyes and ears, whereas the actuators could be like legs and hands, through which they are going to perceive the input from the world and they are going to apply the actions on the world. Also, we can take some other example like software agent. For the software agent, the sensor could be like keystroke through keyboards. It can be some file content or some network packets, etc. So where it is going to perform some actions through actuators, so that actions can be viewed in by means of the monitor or by sending the network packets or some saving some file content, etc. So this is what about agent. So we can say that agent is what? Something going to perceive its environment through sensors and it is going to act upon the environment through actuators. So this agent function can be represented either internally or externally. For example, externally we can represent the agent function by means of a table where we can represent what is the sequence of input and what is the corresponding action. what is the corresponding action. Same way, internally, we can represent the agent function by means of the agent program. So implementing the agent function is what's said to be here as an agent program. So we can say agent function as the abstract mathematical description, whereas agent program is the concrete implementation of the agent function. So the main thing here we need to understand is agent function. Agent function is just a mapping from given input sequence into corresponding actions. So we are going to receive the input by means of sensors. We are going to apply the action to the environment by means of the actuators. So while applying the action, there may be change of state in the environment. Next, we will understand like what is rational agent. A rational agent is the one which is going to do right thing. Given the situation, what right action it is taken on the situation. That is what here we are going to represent as rational agent. For example, if you are going to plunking down an agent in the environment, the agent may apply sequence of actions based on the percept it receives. So this sequence of actions may lead to the change of state in the environment. This change of state can be desirable. This term of desirability is what here we call as performance measure. Means that this performance measure is going to evaluate any sequence of environment states. So we can take this performance measure as the criterion success of the agent behavior. So what is rational at any given time depends on these four things. That is the performance measure that defines the criterion of success, the agent's prior knowledge of the environment, the action that the agent can perform, and then the agent's percept sequence to date. So this leads to the definition of rational agent. For each possible percept sequence, the rational agent may choose any action which is going to maximize the expected value of the performance measure given the evidence of the history of the percept sequence as well as built-in knowledge the agent persists as of date. So the main aim of rational agent is to maximize the performance measure. So understanding this rational agent, next we will understand what is like task environment. So task environment, we can view the task environment as a problem for which the rational agent is going to be a solution. So for specifying the task environment, here we are going to follow a description called PEAS description. So this PEAS stands for performance measure, environment, actuators and sensors. Performance measure is going to mention the agent's criterion of success, how you can measure the success of the agent behavior. So that is what here we are going to call as performance measure. And next one is environment, that is the outside world where the agent is going to interact. That is what we are going to call here as environment. Actuators, that is how the agent is going to control its action. That is what here we call as actuators. And next comes the sensors, that is how the agent is going to perceive the outside world. So based on this, we have to give a description for any task environment. For example, if you are going to take an automated taxi as a for example, if we are going to take an automated taxi as an example, the agent type can be an taxi driver. So for this, we can write the PEAS description as follows. For example, performance measure could be what something like how safe he is driving and fast and then legal and whether we had a comfortable trip or not. Okay, based on this, we can arrive the performance measure. And then environment could be like road, it can be other traffic, it can be like customers, and it can be like pedestrians. And coming to the actuators, so actuators for automated taxi could be like our steering, brake, etc. And then sensors could be like accelerometer, GPS, camera, as well as engine sensors. So this is how we are going to write the PEAS description for our task environment. So after specifying the task environment, now we will understand what could be like the properties of the task environment. Actually, the job of artificial intelligence is to create an agent program. So this agent program is going to implement the agent function, which in turn going to map the given input sequence into the corresponding action. So we can view this agent as like architecture plus agent program. In general, the architecture makes the percepts from the sensors. It runs on the agent program, and the whatever the feedback got from the program means that whatever the actions choices that will be applied on the actuators. So this is what in general we are going to consider as an architecture. So agent is what something like architecture plus agent program. So agent program is the one which is going to implement the agent function, which is the mapping of given input sequence into an corresponding action. So understanding this, the agent is applied in many environments. So the environment possesses various properties. So first property what we are going to consider here is observability. So means that the environment could be fully observable or it can be partially observable. Fully observable in the sense if the agent can completely sense all the states of the environment, then we can say it is a fully observable environment. For example, if we take a chess playing agent. So the environment here is chessboard, which can be completely viewed by the agent. So then we can say such type of environment as a fully observable environment. If the agent cannot perceive complete state information of the environment, if it is able to see only the part of the environment, then we can say such an environment as a partially observable environment. For example, card playing agent. So we can view only partially the environment. In some cases, the agent will not have any sensors at a time, so we can say it is unobservable environment. And the next property of the environment is whether we can able to determine the environment or not. Means that if the next state of the environment is completely determined by the current state of the action of the agent, then we can say that environment is going to be a deterministic agent. Else we can say that agent as a stochastic agent. For example, if we consider like playing a tic-tac-toe game, so here the environment could be like a deterministic, means that the next step we can determine. For example, if we take a stochastic environment, our automated taxi driving environment could be a stochastic environment because we cannot predict what could be happen in the next state, what could be how the traffic could be in the next moment. Okay, so since we cannot determine it previously, then we are going to call it as a stochastic. And a third property of an environment is what, like episodic or sequential. In case of episodic environment, the agent's experience is divided into multiple atomic episodes. In each episode, the agent will receive some percept and it will in turn create an single action. So this is what how the episodic environment looks like. So whatever the action created in the current episode, it won't affect the next episode. Future episodes does not depend on the previous episode. Then we are going to say that environment as a episodic environment. If the current state of the decision taking in the environment, if it is going to affect the future decision, then we are going to call it as a sequential environment. So example for our episodic environment could be like part picking robot. And example for the sequential environment could be like automated taxi, because whatever the decision we are taking now, it is going to affect our future decision. So next property of the environment could be static versus dynamic. In case of dynamic environment, whatever the action taken by the agent, if it is going to lead to the change of the state in the environment, then we are going to call it as a dynamic environment. If there is no change in the state of the environment, then we are going to call it as a static environment. Again, we can take automated taxi as an example for dynamic environment. And next property could be whether discrete or continuous. For example, if we can say that the actions taken by the agent in a discrete term. For example, if a chess playing agent means we can say how many number of input sequence as well as how many number of actions taken. It is going to be in a discrete way. But in case of automated taxi, we cannot count or we cannot say how many actions taken as well as how many input received. So that is what going to be continuous. And last property could be like known versus unknown. In case of known environment, the agent knows the outcome of all the actions. Whereas in case of unknown environment, the agent does not know what could be the outcome of the action. It has to learn in order to make decisions. So this is what like known versus unknown environment. We are going to consider the nature of the environment. So whatever till we discussed is like what is agent, and then how we have to describe the task environment and what could be the nature of the environment. So nature of the environment could be fully observable versus partially observable, deterministic versus stochastic, episodic versus sequential, static versus dynamic, discrete versus continuous, known versus unknown. So as already discussed, so agent is what, which is equal to like agent program plus architecture. So here now we are going to discuss some different types of agent programs, which is going to take actions based on various agent type. So coming to the types of agent, we have mainly four types of agent like simple reflex agent and model based reflex agent and goal based agent and utility based agent. With that, we will also discuss like what is learning agent. So first we will discuss about simple reflex agent. So simple reflex agent is going to select actions based on the current percept. It is going to ignore the history. So perceptual sequence means it is the complete history of everything whatever received by the percept up to the current instant of time. So in case of simple reflex agent, the agent is going to follow a reflexive behavior. Means that here the action is taken by means of condition action rules. You can see the schematic diagram of the simple reflex agent where the agent is going to receive the input from the environment. Based on the input current percept, that is current input, it is going to generate the action by means of condition action rule. So in this figure, this rectangle denotes the current internal state of the agent's decision process, whereas the oval represents the background information used in the process. So in case of simple reflex agent, all the action is taken based on the condition action rules, means that we have a predetermined set of rules which is stored by means of the knowledge base. So if that corresponding condition happens, then the corresponding action will be taken by the agent. For example, if we take the automated taxi environment, if the car in the front is going to apply brake, then agent also has to initiate brake. So this is how looks like a condition action rule. Even though this simple reflex agent looks simple, it is less intelligent. Particularly, the simple reflex agent can be applied in the fully observable environment. Next, we will discuss about model-based reflex agent. In case of model-based reflex agent, it can be applied in a partially observable environment, where we will maintain some history in the internal state of the model. So here we are going to create a model where we are going to maintain the history of the previous state of the agent. So you can see there, it is going to maintain an internal state that depends on the percept history. So whatever currently it can't be perceived, it can be referred from the percept history which is maintained in the internal state. So from the figure we can observe, we are going to maintain one internal state, and this internal state depends on the two things, like how the world evolves independently of the agent or how the actions of the agent is going to affect the world. So based on this, we are going to maintain the internal state through which we are going to model an agent. Again, the same condition action rules is applied in order to take the action by means of the actuators. So this is what about model based reflex agent, which is particularly used for partially observable environment. And next comes the goal based agent. So in case of goal based agent, the each action chosen by the agent depends on achieving the goal. We can see this goal-based agent as what, like something as a problem-solving agent. So the problem-solving agent here is going to have some goal in order to reach from initial state to goal state. So it has to achieve some goal. So whatever the actions taken by the agent is based on achieving the goal. So along with the model-based agent, here we are going to give the goal. So the action taken by the agent will be based on the goals. So it is like, if you observe the figure, so the agent is going to receive the percepts by means of sensors, and then current percept information as well as the previous state information which is maintained in the internal state, and based on that what action I have to choose so that I can reach my goal. So that could be like the goal based agent. So it has to maximize the performance measure. And next comes the utility based agent. In some cases there will be some different goals which cannot be determined properly. So at that time, the utility based agent will help us. For example, we can have conflicting goals. For example, if we take this automated taxi, speed and safety are the two conflicting goals. So at the time, this utility function is going to give the trade-off between the conflicting goals. In second case, we may have many goals which cannot be achieved by certainty. At that time, this utility function is going to give the maximum likelihood of success by which can be weighted against importance of the goals. So which goal is important to that? Based on that, we are going to weight the maximum likelihood of the success. So for example, in goal based agent, it can be divided into like, if the goal is achieved, I am happy. If the goal is not achieved, I am unhappy. But in case of some conflicting goals, or if we having more number of goals, in order to have a trade-off, we are going to make here some utility function. So far, whatever discussed is like a types of agent, like simple reflex agent, model based agent, goal based agent, as well as utility based agent. So that all these agents is going to apply some actions based on some conditions. For example, simple reflex agent is going to apply actions in a reflexive manner, whereas model based agent is going to apply actions based on the model, whereas goal based agent is going to apply actions based on the goal, whereas the utility based agent is going to apply actions based on the utility function. But we don't know how the agent come into being. The solution for this problem could be, first we have to create a learning mission and then we have to teach them. So that is what we are going to call as the learning agent. So any of the above agent, we can call it as like a learning agent. So where the learning can be online or it can be offline. So if we see this learning agent, it is going to have four main conceptual components. One is like performance element, and second one is learning element, and third one is critic, and fourth one is problem generator. So first one we will discuss about performance element. Element is responsible for taking external actions. Whatever so far we have discussed as the agent is what like a performance element, which is going to receive the input through sensors and going to apply actions by means of the actuators. And next comes the learning element. So learning element is responsible for improving the performance. So whatever done by the performance element, the learning element is going to observe it and it is going to do some improvement in order to improve the success criterion. So this learning element actually gets the feedback from the critic that how good the performance element is doing, based on which it can do some changes in the performance element to improve the performance in the future. And the last component could be like our problem generator. So this component is responsible for suggesting actions that will lead to new and informative experiences. That is, based on the learning goal, we are going to give some suggestions which can be used in the future. So that is what problem generator. So this is how our learning agent looks like. That's all. We have came to the end of the session. Thank you.